Hello, calculus. In this video, I'm going to do two examples of logarithmic differentiation, just to give you a feel for how this goes. So the first example I'm going to do is checkpoint 3.54 in your textbook. And so we're going to find the derivative of y is equal to x to the x using logarithmic differentiation. So the first thing I want to do, my first step, is to take the natural log of both sides. So then I'll have the natural log of y is equal to the natural log of x to the x power. And then my second step is to use my log properties to expand the logarithms. And this is going to make our job easier when we actually get to taking derivatives. So if you struggle with this, if you don't quite remember your logarithmic properties, that's okay. You can look it up in an algebra book. The OpenStax algebra textbook has them. And you can review those at any time. So we have a property of logarithms that says I can bring this exponent down and multiply it. So that would give me ln of y is equal to x times the ln of x. And now we're ready to take the derivative of each side. So that's going to be our third step, is to take the derivative with respect to x of each side. And so we get the derivative with respect to x of ln y and the derivative with respect to x of x ln x. So on the left-hand side, we're treating this y as a function of x. So we're actually going to use the chain rule. So y as a function of x is going to be our inside function, and the logarithm is going to be our outside function. So we're going to end up with, from the outside, 1 over y, and then taking the derivative of y, we can just write that as the derivative of y with respect to x, because that's what we're taking. We're taking the derivative with respect to x of this function y. Okay. Left-hand side's a little bit easier. We're taking the derivative with respect to x of a product here. So we can use the product rule. So the derivative, let's give ourselves some nice highlighting in here just to make it a little clearer. So we have the first piece of our product, the function x, and we have the second piece of our product, the natural log function. So I'm going to take the derivative of x, which is just 1. Oh, I wanted that in green. Just 1. And multiply that by the derivative of the ln of x, which is 1 over x. And then I'm going to add that to that. And this time I'm going to leave x. Oops, I messed up. Guys, hold on, sorry. So first I'm taking the derivative of the function in green, which gives us just 1, and I'm leaving the natural log function alone, because that's what the product rule says to do. Next, I'm going to leave the green function alone and take the derivative of the function in yellow, and that's going to give me the 1 over x. So now all I have left is to simplify and to solve to find the differential here. So let's write this all out nice and clean. So I have 1 over y dy dx is equal to the natural log of x plus 1. I'm getting that from x times 1 over x. And I'm going to multiply both sides by y. Get this cancellation here. And then I have the derivative of y with respect to x is equal to y times ln of x plus 1. And that's my final answer. All right, I'm going to do the next checkpoint for you. This one looks a little bit scarier, but it's okay. We're going to follow those same steps. 3.55. And so we're going to want to take the derivative of this function. Y is equal to the tangent of x all raised to the pi. And it's raising that to the pi that's messing us up. But we can handle this. We're just going to take the natural log of both sides. So I have the ln of y is equal to the ln of the tangent of x to the pi power. I'm going to use that same property of logs I used in the last example to bring that pi down. So we have ln of y is equal to pi times the ln of the tangent of x. And now we're ready to take our derivatives of each side. So again, we're going to use the chain rule on the left-hand side because I have my outside function. I'm taking the logarithm of something. And then my inside function is y as a function of x. So when I take the derivative of the part in blue, that gives me 1 over y. And then I want to multiply that by the derivative of the function in red. So I'm taking the derivative with respect to x, which means this gives me the derivative of y, that thing in red, with respect to x. And then on the right-hand side, don't get tripped up by pi. Pi here is just a constant. This is a number, right? So we don't actually really need to worry about that. That number is going to be multiplied by whatever our derivative is. So we're going to have pi times whatever our derivative is inside there. And here we have a classic chain rule situation. I have a function inside another function. So again, we're going to use the chain rule. So my outside function is ln. My inside function is tangent of x. So we're going to peel this function. My first thing that I do is I take the derivative of the part in blue, and that gives me 1 over tangent of x. Then I multiply that by the derivative of tangent, which is secant squared x. If you didn't know that, you could look it up. It's okay. But I do recommend that you start to commit those to memory because they do come up in calculus 2 quite often. All right, so this is what we have now that we've taken our derivative, and now our goal is to solve for the differential for dy of dx. So what I'm going to do is multiply all through by y, and that gives me dy over dx is equal to pi y times secant squared x over tangent x.